So, they want to see if caffeine increases an individual's heart rate. We've got volunteers. We're going to measure their pulse rates. They're going to drink some cola with caffeine and then measure their pulse rates after. And then calculate the increase in pulse rate. We're going to have some sort of control group, right? So here we go. We also have to be, sorry, this first part, sorry, it's confusing. But the first part, it's just kind of setting it up, right? And talking about confounding. You have to be careful with confounding. People might just be excited, right? Their heart rate might go up. You might have just gotten a text that you've been waiting for from a certain person. And it just made your heart rate go up. Perhaps it even skipped a beat. So you have to be careful with these things, especially, right? If you're going to drink a cola, they have sugar in them, so you might be responding to the sugar. And then the second part is actually more easy. I think it's easy to understand that there are all these confounding factors in experiments. I think that you guys are good at figuring this out. We do need to talk about how we would sample. We have a class of 30 students who volunteer to be subjects in the caffeine experiment. So how would we randomly assign 15 students to each of the two treatments? So using 30 identical slips of paper. So we would name them what? 1 through 30. So number 1 through 30. The papers, right? And the subjects. And then we would draw 15 pieces of paper. To draw 15 numbers. And select those numbered subjects. For experiment. And the remaining subjects for control. So right, we would have some of them drink maybe a caffeinated. The best thing would be to have them drink like a Coke and then drink a caffeine-free Coke, right? So then you're actually measuring just the difference in caffeine. So that's nice. All right, using technology. We're going to, again, number the subjects 1 through 30. And I'm going to just talk it out. I didn't want to do one of these or move on without showing you like a complete response, right? This is what we're looking for, right? You have to explain every single piece. So now I'm going to talk these other ones out. Using technology, well, we're going to use this command, randint, and we would go 1, 30. So we're going to, in the same as we did before, we'll number those subjects 1 through 30, and then we'll use randint 1 through 30. And actually, we could just do this 15 times. Unfortunately, I'd be willing to bet that if you did 15, you're going to wind up with a repeat. So you're going to have to actually do rand in 130 until you select 15 individual numbers. So this might not work. If you did this 15 times without repeats. So selecting 15 numbers without repeats. We would take those 15 people, put them in an experiment group, and the remaining we would put in a control group. How would we use table D? So again, number of the subjects. I'm just going to write that down. Number of the subjects, 1 through 30. And now we're going to go, we'll have to say, hey, 1 through 15. We'll call 1 through 15, we'll assign to experiment. So 1 through 15, you will assign to experiments. Oh, I'm sorry, no we're not. So, the first 15 selected. From table B. Will be in the experiment group. Alright, let's do it. Alright, so we'll go to table D. And we'll just select, I don't know, let's start at 123. So we'll start at line 123. Okay, and we're looking for 2-digit numbers. If we find a 2-digit number, and we're looking for them up to 30, right? So any 2-digit number, 1 through 30, is going to count as success. Anything else, we move on. So 54 is not going to work, right? So no 54, no 58. Hey, number 8 just got selected. Number 15 just got selected. Number 7 just got selected. 27 got selected. 10 got selected. 25 got selected. There is no 60. How many are we on? 1, 2, 3, 4, 5, 6, 7. 27 got selected. 55, no. 89, no. 23 just got selected. 30 just got selected. 63, no. 41, no. 84, no. 28, yes. What are we on now? Darn it, I lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've only selected 10. Darn it. 18 just got selected. 11. 71 just got selected. Or no, did not. 3 just got selected. 12. 50 is not going to count. 90 is not going to count. 1 just got selected. 13. 43. 6. 7, no. 72, no. 71, no. 59, no. 67, no. 58. 27 just got selected. Uh-oh. But we already chose, oh no, we chose 27 twice, didn't we? No? We did. So we can't count that one. This 27 is out as well. 61, no. 19, is 19 selected? You know what I should do? I should actually put, we selected number 8. 15. 7. 27. 10. 25. 23. 30. 28. 18. Number 3. Number 1. Number 19. And it looks like also now number 15. Where are we at? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. One more. 96 is out. This 96 is out. 74, 61, 21. And there we go. We just selected. Do we? Ah, thank you. That 15's out. Awesome. 37, 82, 37, 18. No, we've already selected 18. 68, 18 again. No, 44. No, 23. Already done. 51, 19. Nope. 19, no. 62, no. 10 has already been used. 33 doesn't count. 94, no. 44. 96, 92, 71, 99, 31, 36, 80, 97, 41, 92. Come on. Not yet. 40, 19. Already done. 3.
There. It's already there.
43. 90, 99, 94, 77, 25? Dang it! 33. I just can't end until it's done. I just feel right. 6? Yeah? Alright, finally. I don't know if I've ever gone through that many lines of table D with like so few numbers. That was a lot. Alright. Wow. Okay. Okay, there we go. Done. I feel like I just skipped a slide, but I didn't. Okay. We've got to explain the 4 principles of experimental design that were used in this study. Yeah.
No.
So you need to randomize, right? Compare. I don't know. So the thing that I would encourage you to memorize is how to make one of those flowcharts. Because if you make one of those flowcharts, each one of those elements are contained in it. So, for instance, and I'll make one for this. And this is the approach that I'll take. So we're going to have some subjects. Okay, so first of all, let's talk about what is it. We're examining the effect of in-class laptop use. So they're asked to attend just a lecture. They get their laptops. They're going to take notes. Some are also supposed to take notes, but they're also given some like side tasks to do while they're taking notes. They're supposed to replicate, or supposed to simulate like web browsing, right? Because I mean, if you have a laptop and Wi-Fi in front of you, and you get a little bored, you just might be tempted to, I don't know, surf the internet, right? So they're trying to see, and then they give them a comprehension test at the end, and see how they did. So first, we're going to have our, how many subjects? We have 20 multitasking, 10 wait. So we've got our 40 subjects. And so we're going to take these guys. And then we're going to use a process of randomization. Random assignment. Oh, that's really bad. Alright, so we've got the element of randomization in there. We're going to assign some to a control, which is, so this is our control, which is without multitasking. And this one is with multitasking. So there's our control. There's our experiment group. So that takes care of the aspect that we need to do where we put a control. Great blessing. Okay. Then each are given some sort of assessment. That didn't happen. And then we're going to compare the two. I'm out of room. Maybe I can fit. Alright, so alright, so our we have and we're going to put control. We're going to have 20 subjects in here. We have 20 subjects in here. All right, so we'll talk about what each of these represent, like in PowerPoint and here. Okay. So we're going to look for, did we compare? Was there some sort of control? We need replication, and then random assignment. So here we go. Replication, I don't know, 20? So replication is talking about, did we do it enough times? Were there enough subjects? Did we do the experiment enough that we would eliminate some confounding factors? I don't know, 20 is not a lot. Really, the magic number is 30. For a sample size to be large enough. So I don't know. Maybe a replication was addressed, but in this, so this would speak to the replication. Were there enough subjects? Random assignment is clearly that assesses the random. So we're also going to compare our results. And from that comparison, they found that the multitask students did significantly worse. 11% worse. 11% worse? I'm not sure exactly what they're trying to say. All right, and then we have our control aspect as well. So. All right, I'm going to write down the 4 elements because that's kind of all over the place. So our 4 elements are, I don't get them in order because it feels to me that they're out of order. But there must be some comparison. We have to have randomization. You must have replication. And then you also need a control. Maybe not in that order, but that's all. So to answer your question, do you need to memorize what these are? Not really. But you do need to know that if you're being asked to state what let's say, design an experiment, all of these need to be addressed in that statement. But if you do this, if you do a flowchart like this that includes random assignment, a large enough sample size, or a large enough group, so that includes, and then you've assigned them to a control and an experiment. At the end, you found some way to compare the 2 groups, then you've done all of this. This is the way that you should do this. You can write it out in a paragraph, but if you do this on on your AP exam, the grader is going to like it. It's easier to look at and understand. Yes?
So where does the replication?
It's just, so replication is just having enough, doing the experiment on enough subjects.
So you're not like redoing the whole experiment, you're just doing it
Exactly. Yeah, so I mean, there would be better replication in this case if we had 100 subjects. And we assigned 50 to our control and 50 to our experiment. That would be much better. That would address the issue of replication much better. Cool. And so I jumped the gun because we're going to design a completely randomized design for this experiment. We're going to write a few sentences, but we could actually just, instead of writing sentences, I really like the flow chart. So how do these different types of television shows impact young children? We're going to recruit 60 40-year-olds. So we got our group, we got 60 40-year-olds. So there's our subjects. We're going to have them watch 9 minutes of a fast-paced children's program. They're not 40 years old. But hey, that could be fun too. Therefore, it's okay. They are 4-year-olds. All right. And what are they going to do? They're going to watch fast-paced, slow-paced, or they're just going to draw. So we're going to go fast, slow, draw. Fast, slow, or just draw. These are going to be assigned random and I'm just going to put rand. So they've all been randomly assigned to these groups. How many are we going to randomly assign? Well, if we've got 60, then we're going to have 20 here, 20 here, and 20 here, each randomly assigned to each group. After the 9 minutes, they're going to complete several tasks, including tests for mental ability, So now we're going to test them. And then we're going to compare the results of the test. And that is going to work. We probably want to include a few sentences as well, just to say, just kind of explain what this double mess means. Either that, or we could state in our little bubbles a little more clearly exactly what's going on. I believe drawing is the, I think this is our control. Not watching anything at all. Oh, no, they get to just draw, so they're not going to watch any TV at all. Because what are we trying to do? We're trying to find out how different types of television shows impact children. So we want to make sure that it's to compare it to this control, so we can see that it's actually the television shows that we're measuring, and that there's not something else going on. All right. I just liked this. It's really, there's really no work to be done. It was just cool. It turns out that they gave these people a placebo, and so without ever like giving them any medicine, right? They told them the placebo. They were like, "This is an expensive pill," right? Even though it didn't work. It was just a placebo, and they found that people responded to the more expensive placebo more positively than they responded to the pill that they said was really inexpensive. So I just thought it was really interesting. We're just talking about placebos. It's an interesting study. Anyhow, I just thought it was cool. Okay, so now we need to block. Okay, popcorn lover, such as myself. I used to have a weird thing with popcorn. I was extremely anemic. They're about to give me a blood transfusion. Like for real. I was internally bleeding somewhere. They couldn't find it. But I had a lot of surgeries and stuff. So there's a thing called pica for people that are anemic. Pica is a weird craving. A lot of times people will, if they're very anemic, they'll chew ice a lot. Right? That's their pica. Sometimes they'll like eat dirt, like weird stuff. They'll crave weird stuff. Mine was popcorn. I ate popcorn all day. Like I would bring it to work and eat it while I was working, and eat like a few bowls of it at home. I just ate popcorn like all the time. Here I would have to eat microwave popcorn, and then at home I would do it in just like the one of those cool. I would do one of those cool poppers that does it like with just olive oil. I would just do olive oil and salt. But interesting. So I don't eat so much popcorn anymore, but I still love it. All right. So what are we gonna do? She goes and buys 10 bags of 4 different varieties of microwave popcorn: butter, cheese, natural, and ketchup. All right. So now we've got 40 bags. Problem is that if she just separates the bags, if she just randomly selects bags to be in control and experiment, is it a girl? Yeah, she might wind up with a disproportionate amount of one brand in the group, and she might actually just be measuring the brand. So she's going to have to block, right? So she's going to have to separate these 4 varieties and put them into these different groups, right? So I would say that what she should do is go ahead and put variety 1 in a group. And then put variety 2 in a group. Put variety 3 in a group. There are 4, right? And then variety. So she's going to put these all, separate them, right? Okay, I'm done. I have to pause for a second. So I was having a moment, having a hard time identifying the factors, right? It's the 2 factors are popcorn button or recommended time, right? Those would also be described as our explanatory variable. I prefer to call it factors, so because I don't want that to get confused with bivariate data, right? With your least squares regressions. So then you're going to take this one and you're going to randomly assign. So I'm going to just put rand here. So you're going to randomly assign. Well, each variety, how many do we have? 10 banks, so 10. 10, 10, 10. We're going to go ahead and randomly assign 5 to, I'm going to call it pop for the popcorn button. Just because I'm out of space, you'll want to actually write down popcorn button, right? And then here we're going to do 5 to recommended time. And you're going to do the same thing here. I'm probably going to run out. And then we're going to compare. Man, I keep thinking so we'll compare number of kernels. We're going to have to do the same thing with this one. Again, it's going to be a random assignment. And then 5 pop. It's just going to look, we're just going to be, right, 5 recommended time. Over here. Rand. And we're going to go 5 pop. And also these need to be compared. Comp Ks, pre-and-compare kernels. All right. Recommended time. And then we're going to compare kernels. And then these guys as well. Just got so. Alright. And that is how you would have, how you would carry out this random assignment. It can get crazy. Obviously, I've abbreviated and also run out of time, so when you're going to do this, you're going to actually want to explain what this all means. As well as write this on a text, I would get some points. Maybe the grader would want to interpret what I wrote, but I need to write a little something to go along with it. It's pretty messy. But I'm just running along. Give you an illustration of how that looks. That's all. All right. Excellent.